had some questions on problems with finding, like using remainder theorem and factor theorem. So I have like a couple of examples. Like,
Okay.
So one of them would be like f of x equals 4x to the third minus 3x squared minus 8x plus 4, and then they did like a little semicolon and x minus 2.
Meaning x minus 2 is one of the solutions?
Well then.
What else that would mean, but.
Well, the question says use the remainder theorem to find the remainder when f of x is divided by x minus c.
Okay.
So x minus c.
Okay. So how are we going to do this? In other words, what we need to do is divide that polynomial by that polynomial. We can either do it with long division or we can do it with synthetic division. And if we do it with synthetic division, the last number you get is the remainder. Right.
Okay.
You've had synthetic?
Yes.
Let's do it.
So is it better to do it with synthetic division or long division?
I think synthetic. There's no reason. When you do it with long division, you're just writing the variables over again without need.
Yeah.
Do it with synthetic, the only thing you care about are the coefficients. As long as you have every variable represented here, which we do, then instead of dividing by x minus 2, what's going to go in the box?
Plus 2.
Uh-huh. And now synthetically divide, what goes here?
4.
Here?
8.
Here?
And then 5.
Here?
10. 2. 4. And 0.
Well, we're adding, remember.
Oh, we're adding. Okay, yeah.
So this is the remainder.
Okay.
In other words, this would be the quadratic. It would be 4x squared plus 5x plus 2 with a remainder of 8.
Okay.
Seems strange to me. Did we do all of that right?
No, I think that is right because I checked in the back of the book and that was the answer. I just didn't know how to do it.
Okay.
Well, that's right. And also, the second part, it says to use the factor theorem to determine whether x minus c is a factor of f of x.
Okay. Is it? In other words, for it to be a factor, for x minus 2 to be a factor of f of x, has to give you a remainder of 0.
Okay. So that would mean no.
Exactly. That's the only thing that qualifies to make it a factor is if you get a remainder of 0. And that's what the remainder theorem says, is that it's only a factor if the remainder is 0.
Oh, okay. That's a lot easier than I thought. Like, the fancy theorem words were confusing me.
Yeah, well, the rational factor theorem is a little different. That's a little more difficult, but is that another problem, or probably is? It's probably not the same problem, but maybe.
Yeah, there's like another set of problems is like listing the potential rational zeros.
Yeah, okay. So are they asking for the zeros of this function, or do they give you a different one?
No, it's a different one.
Okay, give me the different one.
Okay, f of x equals 3x to the fourth minus 3x to the third plus x squared minus x plus 1.
Okay. Here's what the rational factor theorem says. Who knew it was this hard, but it is. In other words, factoring quadratics is a piece of cake compared to factoring cubics or quartics.
Mm-hmm.
There's no quadratic formula you can plug it into. The only thing that you know at this point is that if there is a rational factor, has to be rational, its numerator is a factor of that number, the constant, and its denominator is a factor of that number.
Wait, but what does it mean, rational factor?
Rational factor means the factor is going to be x minus a rational number, either that or x minus a half. It's not going to be square root. That's not rational.
Okay.
Okay? In other words, there's a lot of quadratics that don't give you a rational factor. You get a square root as an answer.
Mm-hmm.
But the rational factor theorem, that's the only thing it says. In other words, this does not have to have a rational factor. It could have two irrational factors and it could have two imaginary factors. Most likely it has 4 zeros because it's a fourth degree polynomial. But what the rational factor theorem says is that if we're trying to find the zeros of this, a good starting place is to see if there's any rational factors.
Mm-hmm.
Okay? If there are any rational factors, then the numerator has to be one of the factors of that number there, and the denominator has to be a factor of that number. So the possibilities are plus or minus 1 in the numerator, because both of those, in other words, minus 1 times minus 1 is also equal to plus 1, and plus or minus 1 or plus or minus 3 in the denominator, which means our possibilities are plus or minus 1 and plus or minus 1/3. That's it. That's our only possible rational factors.
Okay.
Okay? Now, if we want to go ahead and solve the problem and find what the rational factor is, then we need to start trying some of these. And that truly is the next step. Okay? The way I'm going to try them is by synthetic division. If I try one and it produces a 0 remainder, I will have found the factor. You with me?
Yeah.
Let's try 1 since it's the easiest one to try. Then I'm going to try minus 1, then I'm going to try 1/3, and then I'm going to try minus 1/3.
Wait, so if the problem gives you like 10 different ones, like plus or minus 1, 1/3, like 1/2.
Then it's a nightmare. I'm serious. Then it's a 20-minute problem.
Oh, wow. Okay. So you have to try each one of those?
Well, they're going to give you simple ones, yeah. And notice that this only produced 2 possibilities, or 4, actually.
Yeah.
Normally, I'm looking at a list of 12 to 16 possibilities.
Wow.
Just kind of have to go through each one of them, trial and error. There are a couple of other tests to determine whether one or whatever one you're trying might be outside the range. But I don't know if you've had that or not. Where upper bound and lower bound, have they talked to you about that?
No.
Okay, well, let's stick with this. So let's divide our polynomial by the +1 answer and see what we get. Okay, I know you know how to do it at this point, so I'll just do it and you tell me if I make a mistake. Is that a rational factor?
Yeah.
No, I got to get 0 in this last spot. If I get 0 right here, then it's not a rational factor.
Oh, so if it's not 0, then that wouldn't
That's
be...
not a factor. X minus 1 would not be a factor. Let's try minus 1.
Wait, but what about, is rational factor and rational 0 the same thing?
Not really. Rational 0 means that for something to be a factor, you actually, I think, meant the zero remainder theorem. There's two theorems. There's the rational factor theorem, which is this one here. And then there's the zero remainder theorem, which says that something is only a factor if it produces a zero remainder when you divide it.
But isn't that what you just said?
It is, but what we produced was a remainder of 1. So that was not a factor. That was not a factor. We're looking for factors. I've tried plus 1, now I'm going to try minus 1.
Okay. Wait, but in the problem it says that it says to list the potential rational zeros.
There they are, right there. There's 4 potential ones.
Oh, okay.
There's plus 1, there's minus 1, there's plus 1/3, and there's minus 1/3.
Okay.
I got those from that. In other words, if you put all combinations together, this is what you get.
Yeah, okay.
You can have 1/1, or you can have 1/3. Okay, so let's try this one. I'll drop that down there. That becomes minus 3. That becomes minus 6. That becomes 6. Becomes 7. It doesn't look like this is going to be it either. No. So that's not 0 either. So we'll try the harder math, but not that hard. Not 0 either. And we're going to try the last one. Now the problem with doing these kind of problems is if you make a mistake anywhere along the line, you're going to get screwed up and not know where you made your mistake. I don't think I've made a mistake, but you never think you made a mistake when you make one. Let's just try one more of these. Let's see. This is minus 1. I didn't do plus 1/3 correct. Let's try plus 1/3 one more time. I didn't do the math right. 1/3 times 3 is 1. Minus 2. Oh, yes, I did. That's what I had before. Sorry. Go back and try. 1/3. Okay. Now that's minus 1. Minus 4. 4/3. 7/3. 7/9, minus 7/9, minus 16/9. Doesn't look like this is going to be it either. 16/27. No. So why would they give you one that doesn't have a rational factor? Is that possible?
Yeah, because, no, it's good that you showed me because now I know how to find the zeros, but I think in these particular problems, it says to, just list the potential rational zeros.
It wasn't to solve them. Okay, I got you. So
but some of them
they didn't necessarily give you one that could be solved. In other words, they didn't give you one that actually had a rational factor.
Yeah.
Like this one here.
Yeah, I mean...
If I put are you familiar with Wolfram alpha at all?
That sounds familiar. Isn't that like a...
It's like a calculator on the web.
Yeah, yeah.
If I were to put that into Wolfram Alpha, it would tell me what my zeros were. And it wouldn't list these four because obviously there are not any rational factors to this. We tested all four possibilities. None of them worked, which means that this must have either complex, imaginary, or irrational factors. In other words, maybe the factor is square root of 3 or something, which is irrational, or x minus square root of 3. So hopefully they'll give you one that actually has one of these work. Do they have more for you?
Yeah, they have other ones, but...
Okay. And the other way they're going to give you these problems is they're going to give you the polynomial and they're going to give you one or two solutions and then say solve for the rest.
Yeah.
Well, when they do that, divide your polynomial by the solution they give you and whittle it down to a quadratic. Once you get it to a quadratic, you can always use the quadratic formula to find the last two factors.
Yeah.
But if they give you an imaginary solution, you always know those come in pairs. So they're really giving you two solutions if they give you one imaginary solution.
Okay.
If they give you an irrational solution, those also come in pairs. So the conjugate is also a solution.
Okay. Okay, so there was like another type of problem that I was having trouble with, like, just like as like a general question, how would you find real zeros? Was that what we just did?
We tried. We tried to. Unfortunately, the very first thing you can try is to look for rational zeros. And that one didn't have any.
Right.
And now what is it's not a pre-calc problem anymore. That's a post-calculus problem.
Okay.
They don't teach you how to find the irrational zeros.
Yeah.
Not unless you can whittle it down to a quadratic. Now, if they were to give you, say, one of the imaginary solutions to that last one, well, then we would have two solutions. We could divide each one into the polynomial, whittle it down to a quadratic, and then find the other two solutions. So we would find all four solutions. But unless they give you a solution, and, you know, if there is not a rational factor, then it's real hard to find the solutions. It has to be a pretty special polynomial, like one that lends itself to grouping or something like that. You end up, the first mathematician that solved these things wasn't until like 1700. And the kind of answers you get are answers that look like this.
Oh.
Really weird looking answers.
Yeah.
And they haven't taught you how to do that. In fact, I don't know how to do that. Other than going to a calculator. A calculator will always give you the zeros. If I put that last function into Wolfram Alpha, it immediately gives us the zeros. And I can do that if you'd like, but it doesn't sound like that's what they wanted. They wanted you to just list the possible rational factors.
Exactly. So I think we covered that.
Okay.
Thank you. Okay, and then, but if it, for example, if it doesn't give you the x minus something, so how would you find the zeros then? Like if it's f of x equals x to the third plus 2x squared minus 5x minus 6, then how would you find the zeros from there?
Is this what you said?
Minus 5x minus 6, yeah.
Okay. Okay, I'm looking at it, it doesn't lend itself to grouping. For something to lend itself to grouping, the ratio of that to that coefficient has to be the same as the ratio of that to that coefficient. In other words, it would have to be a 2-to-1 ratio. It's not. So I can eliminate grouping as a possible way to find a factor. The next thing I would do would be to look for rational factors. Well, what do I know about a possible rational factor? The numerator could be plus or minus 6, plus or minus 1, plus or minus 3, plus or minus 2. The denominator can only be plus or minus 1. You see why? The numerator has to be a factor of 6.
And then the other one, 1.
Exactly.
Okay.
So my possible rational factors, if I combine everything here, is the numerator. All 4 of those. In other words, if I simplify this thing, I get plus or minus 6, plus or minus 1, plus or minus 3. So those are our possible rational factors. My next step is to try each one of them randomly until I produce a 0 as a remainder.
Oh, and okay, so that's...
Whenever I produce the 0, I have found my factor. Once I find one factor, I can divide it into that, which will reduce this to a quadratic. In other words, my factor will always be linear. It will always be x plus or minus one of these.
Okay, so we don't have to do all of them right now, but let's say if it was like 6,
okay,
and it happened to have a remainder of 0, then would you plug the 6 into to the x?
Here's what you do. I'll go through it real quick just to show you what you're going to do. If it worked. Okay. If 6 worked.
Okay.
It's not going to work, but...
Okay.
If that was 0, then I've already divided this by my factor, and my remaining quadratic is that. Now, which means x squared plus 8x plus 43. So I would have found one factor, which would be x minus 6, and I can get the other 2 factors by using the quadratic formula on that. I found all 3 factors. That's why I say that no matter whether you start with a quartic or a cubic, you need to get it down to a quadratic. And you do that by each division. Now, this act of synthetic division here is particularly valuable because not only it tells me whether or not that's a factor, but it gives me the result, quadratic, after dividing by that factor, which my next step is half done for me. I don't need to go back and redivide to figure out what the quadratic factor is.
Okay, but it says to find the real 0. So what it means by that is if the thing equals 0, whichever one of the either 6, 1, 3, or 2, whichever one has a remainder of 0, you just plug that into the original equation. Is that what it is?
No. Do you happen to know what one of the zeros is on this, so we can cut to the chase?
No, I haven't done this one yet, but I don't know, but I think I know what you mean, though. So it would be...
You don't have to plug anything in. In other words, you already have the resultant quadratic. When I take this cubic and I divide it by the linear factor that is truly a factor, I will end up with a quadratic.
Right.
Now I know how to factor the quadratic. I can always use the quadratic formula if it doesn't factor nicely. So there's my 3 factors. In other words, I find one by looking for a rational factor. and then I get the rest of them by eventually getting this thing down to a quadratic. In this case, is all I have to do is find one rational factor.
Yeah.
As soon as I find one rational factor, I will have that factor and I will have a quadratic. And I know how to factor the quadratic, so now I know all three zeros.
Quadratic formula. Okay, okay, that makes sense.
Yeah. Is this a real problem that we're supposed to find the solution?
It just says to find the zeros, so I guess.
Well, it's
that's all it said.
Not 1. Is it minus 1? Now we got it. So we found it.
Yeah, so that was minus 1.
Okay, so that means x plus 1 is the linear factor. And the rest of the factor is x squared plus x minus 6. And that factors, I can factor that without the quadratic. That becomes x plus 1 times x plus 3 times x minus 2. So your three zeros are minus 1, minus 3, and 2.
Oh.
That's how.
Okay.
Once you find the first rational factor, which we did by using minus 1 in the box, reduce the 0, that tells us that x plus 1 is a factor of that polynomial. And when you divide that polynomial by x plus 1, you get this.
Oh, okay.
That factors into that times that.
Oh, so you use the quadratic formula on x squared plus x?
I could have, but I didn't need to. It factored easily. It factored into my normal factoring.
Okay, I got it.
If I couldn't factor it, make that a 5, now I got to use the quadratic on it. But as long as that was a 6, it factored quite easily.
Okay. Yeah, next time I do a tutor session, I think I'm going to need to work on factoring, because that's a big issue with me. I've been asking my teacher and my friends and everything, and I just can't understand factoring very well.
I can help you a lot with factoring.
Okay.
I kind of have my own method. I don't really like any of the methods that are currently taught. I don't know if they taught you the California method or the diamond method or trial and error or whatever. But I have my way, and it's pretty simple, pretty straightforward, and easily learned.
Awesome. Okay, so I'll schedule that for next time.
Okay.
All right. Well, thank you.
You're welcome. You good to go for tonight?
Yeah, I think I'm good. Thank you.
Okay, Sonia. Have a good night.
You too. Bye.